In the realm of modern technology, few innovations have captured the imagination quite like 3D printing. What was once the stuff of science fiction is now a reality, shaping industries from healthcare to fashion, and even our homes. But how does 3D printing work? This video will embark on a journey to uncover the fascinating process behind creating objects with 3D printers. The concept of 3D printing. An introduction. Imagine holding an object in your hand that was never manufactured in the traditional sense, but rather built layer by layer, almost as if it materialized out of thin air. This is the essence of 3D printing. At its core, 3D printing, or additive manufacturing, is a process that creates three-dimensional objects by adding material layer upon layer, guided by a digital model. Unlike traditional subtractive manufacturing methods that remove material from a solid block, 3D printing builds objects from the ground up, making it incredibly versatile and efficient. Step 1. The digital blueprint. The journey of any 3D printed object begins with a digital blueprint. This is essentially a detailed, computerized design of the object you want to create. Designers use computer-aided design, CAD, software to create this 3D model. CAD programs allow for intricate designs, from the simplest geometrical shapes to the most complex structures. If you're not a designer, no worries. There are countless online repositories where you can download pre-made 3D models. Once the design is ready, it is converted into a format that the 3D printer can understand, typically a file format known as STL, stereolithography. This file contains all the information about the object's geometry, ensuring that the printer knows exactly what to create. Step 2. Slicing the model. With the digital blueprint in hand, the next step is slicing. No, this isn't about cutting your model into pieces. Rather, it's about preparing it for printing by dividing it into thin horizontal layers. This is done using slicing software, which takes the 3D model and breaks it down into thousands of tiny slices, often as thin as a fraction of a millimeter. Each slice represents a single layer that will be printed. The slicing software also determines the path that the printer's nozzle will follow to lay down the material, as well as other crucial parameters like the speed of printing and the temperature of the printer. It's during this phase that decisions are made about the object's internal structure. For instance, will it be solid or will it have a honeycomb structure inside to save material and time? Once the slicing is complete, the file is sent to the 3D printer, and the real magic begins. Step 3. Printing the object. Now, we arrive at the heart of the process, the actual printing. There are several types of 3D printers, each using different technologies to create objects. However, the most common and accessible method is fused deposition modeling, FDM. In FDM, the printer heats a filament, usually made of plastic, until it becomes malleable. This filament is then extruded through a nozzle, which moves according to the path determined during the slicing process. The printer deposits the material layer by layer, starting from the bottom and working its way up. Each layer cools and hardens almost immediately after being laid down, allowing the next layer to be added on top. The layers bond together to form a solid object, and this continues until the entire object is completed. The type of material used can vary widely, from various plastics to metals, resins, and even food. Some advanced printers can combine multiple materials in a single print, allowing for objects with different properties in different areas. Step 4. Post-processing. Once the printing is complete, the object is almost ready to be used, but not quite. Depending on the complexity and the intended use of the object, it may require some post-processing. This can include removing any support structures that were printed to hold up overhanging parts of the model, sanding the surface for a smoother finish, or curing the object under UV light to strengthen it. For certain applications, additional steps might be necessary, such as painting, coating, or assembling multiple printed parts. The level of post-processing needed can range from minimal to extensive, depending on the desired final product. The impact of 3D printing. The process of 3D printing might sound complex, but its implications are far-reaching and revolutionary. It has democratized manufacturing, allowing individuals and small businesses to create prototypes and products without the need for expensive tooling or mass production. In industries like healthcare, 3D printing is used to create custom prosthetics and even human tissue, tailored to individual patients. Moreover, 3D printing is fostering innovation by enabling rapid prototyping, allowing designers and engineers to iterate on the designs quickly and cost-effectively. This has accelerated the pace of technological advancements and opened up new possibilities in fields ranging from aerospace to fashion.